Hi there, today our topic is genetic algorithms. It is one of the machine learning algorithms that is used to get optimized results. That is, it takes the input, processes it, and gives us the best result possible. It is widely used in business, scientific and engineering domains. Let's see the flowchart of genetic algorithms. Initially, after starting the process, it creates an initial random population of organisms. In the next step, it evaluates fitness for each organism. Later it goes to the decision block, and looks for any optimal or good solution found. If yes, it comes to an end. If not, it reproduces and kills organisms and later mutates them. After completion of the entire process, it goes back to the second step, that is, evaluates fitness for each organism, and the cycle repeats until an optimal solution is found. Next, coming to genetic operators. In this we have three operators. 1. Selection operator. 2. Crossover operator. 3. Mutation operator. Let's see what the selection operator is. This is the process of selecting two or more parents from the population for crossing. The purpose of this selection process is to get the offsprings with higher fitness. We have different methods for the selection process. They are roulette wheel selection, Boltzmann selection, tournament selection and rank selection. In roulette wheel selection process, the parents are selected, depending on their percentage of contribution to the total population fitness string, and are selected for mating to form the next generation. Let's take an example for the entire process. 1. Consider maximizing the function f of x where x is interval from 0 to 31. Now let's generate the initial population at random. They are chromosomes or genotypes. Considering the binary and integer values. 2. Now calculate fitness of the random population. In the calculation process, first we need to decode the binary numbers into integers. These are called phenotypes. Next is to evaluate the fitness from the above function, that is f of x is equal to x square. Here we find the fitness values of all the random population. 3. Next is the selection step, in which the parents, generally two individuals, are selected based on their fitness in P, where Fi is fitness for string I, which is a population example as f of x. Pi is the probability of string I. N is number of individuals in the population. NPI is the expected weight. Let's consider a table. Here we are taking 4 strings from the example. In this, the initial population is the binary value. The x value is the integer value. And the other values are fitness, probability of the string, and of the expected count. The expected count is calculated by multiplying the total number of strings with the probability of the respective string. The next operator is the crossover operator. It can be either 1-point or 2-point crossovers. In 1-point crossover, the selected pair of strings is cut at some random position of their segments, and swapped to form a new pair of strings. Let's take an example. Here we are cutting the strings at 1 point and crossing over the segments. That gives us new value. Now let's take an example of a 2-point crossover. Here, we cut the strings at 2 points and cross over the segments with the opposite. That gives us the new values as given below. We are crossing over string number 1, 2 and 3, 4 at different points. Comparing the summation of the previous example, the crossover value is greater than the selection operator. Let's consider a table for crossover operators. In the crossover operator, we need to eliminate the least values. So we are replacing the least value with the highest value from the previous example. The last one is the mutation operator. It is applied to each child individually after the crossover. Bits are changed from 0 to 1 or from 1 to 0 at a randomly chosen position of randomly selected strings. Consider a table for mutation operator. Here we got the best results after applying the genetic algorithm. Our second topic is hypothesis research. The genetic algorithm employs a randomized beam search method to seek a maximum fit hypothesis. This technique is quite different from other learning techniques. The genetic algorithm moves suddenly, replacing a parent hypothesis with an offspring that may be radically different from the parent. The genetic algorithm searches the hypothesis space in a different way when compared to the natural network, which uses backpropagation, but the output is quite similar. The problem in search of genetic algorithm is crowding. It is a phenomenon in which some of the individuals with high fitness than other individuals are selected to reproduce. resulting in the copies of these individuals, and very similar individuals take over a large fraction of the population. The negative impact of crowding is that, it reduces the direct diversity of the population. One approach is to alter the selection function using criteria, such as tournament selection or rank selection, in place of fitness proportionate roulette wheel selection. The third topic is genetic programming. Genetic programming evaluates computer programs automatically. It is specially used in the domains, where the exact form of the solution is not known in advance. It starts with an initial population of randomly generated programs. After initializing, computer programs are evaluated and genetically reproduced. The production of the new programs comes with the application of genetic operators. The programs which are represented as syntax tree, generate a population of random trees and evaluate the fitness. Later selects the programs with good fitness to create the next generation programs. Some random control strategy can be represented as a tree. Well, that's the end of today's topic. Along with the video explanations, we offer notes, mind maps, infographics and more to all the subjects from your syllabus. And also career guidance programs from current working IT professionals. And many more to our supporters. To join our supporters community, use the subscription link given below. For more topics from your syllabus, please visit our website given in the description. If you like the explanation, press the like button and rate us from 1 to 5 in the comments section below. For getting updates on any video we posted, please subscribe to our channel and press the bell icon. We will be back with another concept soon.